Hello there, you're welcome. In this video, we are going to be defining the value of x, as we have x raised to power x is equal to 17. Now, I want you to know that since we have x raised to power x is equal to 17, let us try some integers raised to the power of the same integers to see if we can get 17, as we have x raised to power x is equal to 17. So, 1 raised to power 1 is what? 1. And 1 is less than 17. So let us take 2. 2 raised to power 2 is what? 4. 4 is what? Less than 17. So 4 is not up to 17. So how about 3 raised to power 3? 3 raised to power 3 is what? 27. And 27 is what? Bigger than 17. Now what does this tell us? This tells us that what? The value of x lies between 2 and 3. The value of x lies between 2 and 3 because 2 raised to power 2, which is 2 times 2 is 4, and 4 is less than 17. Why 3 raised to power 3 is what? 27, and 27 is bigger than 17. So the value of x will be between 2 and 3. Now if you look well, you see that we have an exponent of x because x raised to power x. So let us take the natural logarithm of both sides. So that would be what? Ln x raised to power x is equal to ln 17. Now from one of the laws of logarithm, it says that if you have log a raised to power b, that this can be written as what? B log a. In other words, you can see the power was used to multiply the logarithm. The power becomes the base, so that it multiplies the logarithm. It becomes the coefficient of the logarithm. So we are going to be doing the same thing here. This x, we are going to drop it down to here. So x will come down to this place to what? To become the coefficient of the logarithm. So let us put this to this form as they are related. So this x can come to this place. So that will be what? X ln x is equal to ln 17. Now we can't just find the value of x because we have x ln x. So what is going to help us to find the value of x is what we call the Lambert W function. The Lambert W function. Now the Lambert W function states that if you have w x e raised to power x is equal to a. The Lambert W function states that the coefficient of this e, that if it is raised to the power of the same coefficient, what you are going to get as your result is what? Is the same value. Like we can see here, we have x is the coefficient of this e, and this x is still raised to the power of the same x. So what you are going to get as your result will be x. Let me give you another illustration for a better understanding. If you have 2e raised to power 2. Now look at seeing this one, you can see that 2 is what? Is the coefficient of this e. And this 2 is still raised to the power of the same 2. So our result will be what? 2. But how can we now introduce e into this equation so that we can use what? Apply the Lambert W function, because we have ln here and we have e here. So we need to introduce e into this equation so that we can apply the Lambert W function properly. So let me show you something. Do you know that if you have e raised to power ln x, do you know that this is equal to x? Do you know why? Do you know that the reason is that this ln and this e, that both of them are inverse functions. It means that this ln can cancel this e and you'll be left with x. So this x will now be equal to this x. So do you know that this x here, I can rewrite this, since e and ln are inverse function, meaning that they can cancel out, you still be left with x. That means that if I introduce this e into this x, it doesn't affect it because x will still retain its value. So let me introduce Let me rewrite this x. This x, I will rewrite it to be what? E raised to power what? Ln x. So I will rewrite this particular x here in this equation to be this because I want to introduce the Lambert W function inside this equation. So this x will be what? E raised to power what? Ln x. Then we have ln x again. Ln x is equal to what? Ln 17. Now, I need to rewrite this way so that I can correctly apply the Lambert W function. So this can come before this. Then this one I will put this one first and put this one second because I want to rearrange it in such a way that I can be able to apply the Lambert W function. So let me start with this. So that will be what? Then x. Then let me write this. E raised to power what? Ln x is equal to what? Ln 17. Ln 17. Very beautiful. Now, do you notice something? That we have what? Ln x as the coefficient of this e. And this ln x is also the power of this e. So that means that we can do what? We can apply the Lambert W function. As you can see here, we have x as the coefficient of e. And we have x as the power of e. What you are going to get is what? X. So that simply means that if we apply the Lambert W function in this place, what we are going to get as our result will be what? Ln x. So let me apply the Lambert W function. So that would be what? Lambert W function of what? Ln x e raised to power what? Ln x is equal to what? The Lambert W function of what? Ln 17. So if I apply the Lambert W function on the right hand, I will be left with what? Ln x, because ln x is the coefficient of e and ln x is still the power of e. So we have what? Ln x is equal to what? The Lambert W function of what? Ln 17. Very beautiful. Now, remember I told you that e and ln are inverse function. So I need to get rid of this natural logarithm. So I will introduce e to both sides because I want to get rid of this natural logarithm. So that will be what? E raised to power ln x is equal to e raised to power Lambert W function of what? Ln 17. So that means that this ln can cancel this e. So we'll be left with what? X is equal to e raised to power what? Lambert W function of what? Ln 17. Now this is the value of x that can satisfy this equation. Try this out in your calculator and drop your answer in the comment section. Don't forget to subscribe to my YouTube channel. Thank you.